Hello and thanks for watching my video. In today's session we're going to talk about Cisco UCS and its new support for Microsoft SMB Direct, or RDMA, integration with Microsoft SMB. Let's do a quick review of SMB Direct. So SMB Direct is having SMB with RDMA. SMB is your normal Windows file shares. When you're copying files and such, and you're going, / file name or / server / file share, and doing things like file copies and such. This new version, SMB 3.0, is where we got this SMB with RDMA. Well, what is RDMA and why is that important, and why have we added that and talking about that today? Well, what we're talking about first off is the definition. RDMA is remote direct memory access, and it allows me to take a chunk of memory on my server, move it to an adapter, copy it across the network to the other adapter, and move it directly into memory on, say, a client, or vice versa. And what that means in that description is I really bypass the CPU. I end up getting higher throughput because I don't have to have the CPU of the server and client processing this. I have a tendency to get much lower latency, and I get much lower CPU utilization. Along with this SMB Direct, I also get this really beneficial feature called SMB multi-channel. And what that allows me to do is have multiple NICs on my client and server, and for however many NICs that I've set up that allow me to have connectivity directly to each other over the Ethernet network, it will load balance the file copies, the transfers, over those links. So for example, in the environment that I'm going to show you, I have on both the client and the server, I have two 10 gig links, one going to my A fabric and one going to my B fabric. And when I do my test, you're going to notice that traffic is flowing out both of those links and utilizing them completely. Where with most other file transfer protocols, you're only seeing one link utilized. So I get the ability to also have a lot more bandwidth from that standpoint. Now, when it comes to RDMA itself, there are multiple implementations available. There's what's called iWarp, which is using TCP/IP. There's InfiniBand, which is, InfiniBand. And then there's this thing called RoCE. And RoCE is RDMA over Converged Ethernet, and that's the implementation that we're using. Kind of makes sense with Cisco being kind of an Ethernet type of company. That's the implementation that we chose. It also seems to be the most popular in the market today. So let's talk about what's it take in UCS to actually have these capabilities. Well, one of the things that you need the Cisco VIC-1300 series adapters. That's our third generation VIC virtual interface card. Just a quick overview, that supports N by 10G, so depending on what model you get a number of 10 gig links inside it. Also the ability to do native 40 gig flows are supported in it. They come in two different form factors, mezzanine, which is for like the blade servers, but also a PCIe form factor for our rack servers. As with our previous generations, I can build a whole lot of PCIe enumerated NICs and HBAs for my servers with this. And now I'm just getting the ability to add some RDMA enabled ones. These new adapters also support something else that I figured I'd mention because it kind of relates to this technology solution, and that is the ability to do hardware offloads for overlay networks like NVGRE and VXLAN. And of course, the RoCE capability that we're here to talk about today. Now, to actually enable this capability, you need UCS firmware 224 or above, and that is just coming out. You also need, from a driver perspective, the drivers that support the RDMA capabilities, so those will align with the 224 release. You'll just do your normal simple firmware update that you do on UCS Manager, update your drivers, and you have those capabilities available. But how do you actually turn them on in the UCS Manager? Well, in UCS Manager, you've got some QoS settings that you can configure, and for RDMA to function properly, you need what's called data center bridging or lossless Ethernet. So that's the ability to have a priority queue for certain type of traffic, but also so the priority queue doesn't fill up and you take tail drops and you lose packets. You need to have the ability to have what are called pause frames, where you can tell the one side or the other slow down so I don't fill up the buffer, so the priority traffic can be handled accordingly. So UCS has the ability to do that, and so you just simply set up one of your queues to be your lossless Ethernet queue. Then you build your VNIC templates just like you do for any other NICs, and generally you want to build that, one say for your A fabric, one over for your B fabric. And then when you get ready to apply that VNIC template to either a service profile template or service profile, that's when you get the ability to assign an adapter policy. And when you assign that adapter policy, you want to pick either SMB server or SMB client as that adapter policy. You could build your own, but there's a couple predefined in there. And that enables the RDMA capabilities, the RoCE capabilities. And the difference really between server and client is the number of queue pairs and the number of connections that it can handle. And of course, when you've done that, you've also assigned that QoS policy, which gives those NICs the lossless Ethernet. And nothing else is required. I've worked with RDMA from other manufacturers, and you generally have some PowerShell that you've got to go into Windows and do and turn on data center bridging in Windows and set up a VLAN mapping to a certain QoS setting and then the DCB settings onto that. You don't have to do any of that. That's automatically handled once our driver's installed. So very, very simple to get that going. Let's talk about a couple use cases for this. In some very large organizations, traditionally, when they're doing things like hosting, let's say virtualization, building private cloud, big topic out there, what you'll see is people having a big storage array, a storage fabric, and then a bunch of servers working as Hyper-V hosts. And when they're doing the Hyper-V hosts, what they're doing is they're using Windows failover clustering to cluster the servers together, and they're also doing cluster shared volumes for shared storage so that they can have all the storage shared between all these Hyper-V hosts and have failover of that storage. And what you generally run into is some scaling problems there. Depending on the kind of array that you have, you may not be able to get the scale that you want, so you end up building multiple smaller clusters. And that just is kind of more work to manage. In this type of solution, what you do is you set up kind of two different roles for some of your servers. You set up some of your servers to be what are called scale-out file servers. So now they're Windows failover clustered together, and they have shared storage on the back end, but you generally only need like 4 or 8 of these. You don't need a ton of these. And these servers become file servers that are highly available for doing that, / my server / my share kind of environment. And they serve all of the information for your Hyper-V machine. So they've got your VHDX files and your XML files that define the layout of those virtual machines. And again, it's a very small cluster, so no problem with scaling on the storage. I can also take up to 80% of the RAM with those scale-out file servers and make that a read cache, so I can add some additional performance capabilities natively there. And then I take a bunch of servers, say up to 64 today, where you can actually have a Windows failover cluster with 64 nodes in it, and I build that failover cluster with 64 nodes for my Hyper-V hosts, but I don't actually have them have shared storage clustering off of that storage array. Instead, I have them use the SMB file shares off those scale-out file servers to serve the VHDX files to their virtual machines. And then I get really nice performance out of that because I'm using this RoCE enablement where we're going to see low latency, low CPU, high throughput. We're going to see the multi-channel, so I get very high bandwidth, maybe above what I could get if I was doing traditional like storage HBAs. And then, of course, I don't have a scale issue, so I can go up to that max size because I'm not doing that cluster shared volume. Now that plays really well maybe in that medium and larger size environment, but people in the smaller commercial space or smaller deployments in general may want to look at other alternatives, maybe using something like Microsoft storage spaces. And Microsoft storage spaces basically taking a server, put a bunch of hard drives in it, set up volumes and LUNs that you can serve out there, and then set that to serve file shares, and you could do those file shares with SMB3 and RDMA and serve the same kind of functionality to your Hyper-V hosts. So those servers with DAS, direct attached storage, now serve out the file shares to those Windows failover clustered Hyper-V hosts, and you get the same functionality you did in that larger deployment. So those are a couple opportunities. And of course, this will work for plain Jane, hey, I need file shares. Sure, that'll work also. But I find most people are talking about cloud type services today. So let's talk about some demonstrations, and let's do those for you. So the first demonstration I want to do is going to be very real world. I want to take a couple servers here, and they're all set in default mode. And that default mode means that I can do live migration because I enabled that. But the live migration is going to use standard TCP/IP over the network with compression to move the running virtual machine from one server to the other. And then I'm going to change the mode, and I'm going to do SMB, which is going to be my RDMA-enabled SMB, and show you the differences. And let's take a look at things like the CPU utilization. So let's get that started. Okay, so now I'm going to go ahead and switch over to my remote desktop and show you a couple servers here that I'm going to use for this demonstration. So we see that I've got my RDMA Hyper-V host server, and we see right now a virtual machine running on it called RDMA1. And the thing to know about this server is it is running with 96 gigs of RAM. So pretty good sized virtual machine running here. And then I have this second RDMA-FS1, which also has Hyper-V running on it, but no virtual machine. And that's what I'm going to do the move of the virtual machine to. So let's take a look here at our CPU. So looking at cores, we don't see a heck of a lot going on this machine, running 0 to 1%. We see currently about 100 gigs out of 256 gigs used. That's because in demo 2, I've got some stuff going on there that's taking up a bunch of memory. If we look at our NICs, we see the NIC being used for my my lab here, which is my RDP session, but not much else going on in the environment. And if we look around here, there's my RDMA B NIC, and let's find my RDMA A NIC, and there's my RDMA A NIC. So not a heck of a lot going on right now. Let's go over to the Hyper-V host machine right now that's got this VM running. Same type of thing. We see CPU utilization is pretty darn low. We see that I've got about 200 gigs being used on this server. Well, that's because 96 gigs is being used by the virtual machine right now. And if we take a look at my various NICs, there's my RDMA B NIC, not anything going on there. Oh, and there's my RDMA A NIC, and again, not really much going on there. So let's go ahead and take a look at the settings on this server right now. And we see that I've got it set up that I could do up to 2 simultaneous live migrations. I've got my networks identified that are my RDMA networks, my 1 network and 2 network. And if we look at advanced settings, let's go ahead and set that for TCP/IP with compression. Let's go over to my other machine here. Let's go ahead and look at its Hyper-V settings. Let's set it for using compression with TCP/IP. It's also set to use the same network, or networks in this case. And let's go ahead and start our move of this virtual machine. So I'm going to come over here and select it. I'm going to say let's move it. Let's move the virtual machine. Let's move it from where it's at right now to RDMA-FS1. Let's say next. Let's move just the virtual machine and go. So now the move is taking place, and let's watch what happens here from a network perspective. Well, we see a little bit of network traffic going on here. There's a 1.2 megs. There's 1.4 gigs going over that network. Nothing going over the RDMA B network. We see The CPU's at about 40%. Let's look at the other side. That CPU's running about 40%. We see the memory's cranking up as that VM moves over. And if we look at my RDMA network, well, everything's done already. It's already moved the file. So the move's still pretty quick, but we noticed a pretty high impact from a CPU perspective, and we saw from the network perspective, what was that, 2.4 gig or something like that of throughput. So that's pretty good. It's not, it's not terrible. Let's go ahead and move it back real quick. And let's just show it going both directions. And then we'll switch the mode. Alright, so we'll crank this up, and we'll just watch this a little bit more with the CPU and the throughput. So we see the CPU is now cranking up 46%, 42. Let's look at my network here. I see 3.4 gigs over this NIC, which is my RDMA-A. RDMA-B is not doing anything. 3.9 gig, 1.8, very spiky traffic going on there. And it looks like it's just wrapping up. So again, not fantastic compared to what you're going to see here in a minute. So let's go ahead and change our settings now, as we talked about, to using SMB. Let's go over to the other one, do the same thing. So use SMB. All right, that's done. Let's go ahead and move that virtual machine again. So we're going to move it, move the virtual machine to my RDMA FS1, move the virtual machine only, and finished. And let's just sit here for a minute and let's watch what happens. So the move is started. We see my CPU about 3%, 2%. Look at, I get SMB multi-channel, 9.8 gigs, 9.9 gigs simultaneously out of both of these. So that's pretty darn good capability. So I'm getting a lot more throughput. Again, a lot lower CPU. Let's flip over to the other side here. We see the memory's cranking up because the VM's moving. CPU's only at 4 or 5% compared to the fact that we were seeing like 40%. There's the 9.9 gigs and 9.8 gigs going on right there. So again, very high throughput. Very constant throughput. We're not seeing the spikiness that we were seeing previously. And again, that CPU staying nice and low. And it's completed the move, so we'll see everything calm down here. There's all the network is going back to idle. And we never saw the CPU go, what, above 5%? Compared to we saw it at, what, 48, 46, something like that when we were doing the previous move. So a lot of savings, and then we saw a lot more throughput. We saw only one NIC being used in the original. We saw it jump up to 4-point-something gigs. But in this case, we saw a very nice constant 9.7, 9.8, 9.9 gig across 2 links doing my SMB multi-channel. So not bad whatsoever. Now let's take a look at some other demos. So the other one is really benchmark type demos. And that's using SQL I/O. So what I'm going to do here is between those 2 servers is I have a file share set up, and I'm going to use SQL I/O to do some reads, do some writes, and we'll show that with and without RDMA enablement, and we'll look at what happens with the CPU. We'll see what latency is doing, and we'll look at what our throughput looks like. So let's go ahead and get that started. All right, returning to my remote sessions here. Let's walk through what I've got set up. So if we look on this server here, I've got this RAM disk running, 100 gig RAM disk. And what I wanted to do is for the testing, I didn't want, my lab's got, doesn't have super high performant storage arrays. So to remove any bottlenecks of I/O, I'm using a RAM disk. And with this RAM disk, I've set it up as a share. So you can see the little double heads there. So I'm doing a file share off that. If we come over and look at the other server here, this server shows that I've got set up here whack RDMA-HV1, which is that other server, drive Z, the RAM disk. So I've set up that RAM disk as a file share with a drive letter. And on there, I've stuck a file called test.dat. That's, like 16 gigs or 17 gigs in size. And then on this machine, I've got some batch files that run SQL IO. So I'm going to go ahead and execute this, which is a 512K read. And we're going to come over here and we're going to take a look at some metrics. So first off, it's doing this read. And when we look at the CPU, it's running about 3%. If we look at my cores are pretty idle, not a whole lot going on there. A couple cores doing something, but again, about 3%. If we look at my throughput, there's my RDMA ANIC, and let's let that graph build out here. There we go. So we see very constant traffic, pretty darn close to the top end. There's 10 gigs, 9.9 gigs. There's RDMA BNIC. Again, we're seeing 9.9, 9.8, 10 gigs, 9.7. It's very, very constant right around the top end looking at this graph. So very good throughput. Let's look at the impact on the other side. So we're seeing about 3% CPU here. Over here we're seeing about 8%. Because this is actually the server side, not the client. But if we look at that, 8%, core still not dramatically impacted. We look at our throughput, we're seeing 9.8, 9.9, 10 gigs, very constant. Same thing here. We're seeing some very nice constant traffic flowing across the other NIC. So we're getting pretty close to 20 gigs of throughput. And then what I really want to also add on to this is let's go ahead and stop this. And if we look at it, what are we getting for latency numbers? Well, we're getting an average latency of 2 and a max latency of 6 milliseconds. So we saw about 3% on the client CPU, 8% on the server. We see latency of 2 average and 6 max, and we saw just about 10 gig of throughput on 2 links doing SMB multi-channel. Not bad. Let's go ahead and stop this. And now what I'm going to do is I'm actually going to go ahead and I'm going to disable the RDMA functionality on the system. So what I'm going to do is I'm going to do a set dash net adapter RDMA dash enabled $false. And I'm going to do that for my get dash net adapter dash interface alias RDMA star and pipe that in here. So we'll let that run. That takes a minute for it to disable the RDMA functionality. You'll notice that my NICs reset. You probably saw some stuff flash over here while the NICs reset, see not connected. And now they're reconnecting because they're basically coming back up with the RDMA features disabled. So let's take a look. There's my RDMA B NIC now. There's my RDMA A NIC. Let's take a look at a couple things like netstat minus XAN. We notice there's no RDMA. Let's do a get dash net adapter RDMA. And we notice that for my 2 RDMA NICs, I've disabled the RDMA functionality. So now let's go ahead and double check that my file share is still good. Yep, my file share is still good there. Let's go ahead and go back and kick off this exact same SQL IO test. So now that's running. So let's take a look at what's going on here now. So on the client, before we were seeing 3% CPU, now we're seeing 4%. So we've gone up about 1% CPU. Let's look at my 2 NICs here and see what's going on from a NIC perspective. So let's look at my RDMA A NIC, which right now is not doing RDMA, it's just doing plain Jane SMB, and let's see what's going on. Well, the throughput's still pretty good, but you notice it's a lot spikier. It's not very consistent. I am getting multi-channel because with SMB3 you can get multi-channel without the RDMA capabilities, but you notice again it's not very consistent. It's jumping around quite a bit between what looks to be about 8.6 and the 10 mark, so somewhere averaging a little lower than what we were getting before. Let's jump over to the server though, And take a look at the CPU here. Before we were seeing CPU in the 8% range. Now we're seeing that has jumped up into the 15% range. And remember, we're only doing one set of I/O. Think if this were a whole lot of servers hitting this at the same time, the fact that the CPU utilization is about half of what we'd seen before. And we see a lot more involvement from these different cores. We come over and look at the throughput, and the throughput's going to be, similar to what we saw on the other side. It's going to be that very spiky type of traffic. Still pretty good, but we see again it's pretty darn spiky here when we take a look at it. But now let's go back and let's also add on to that. Let's see what's going on from a latency standpoint. So we see the latency's a little bit higher from an average, but the really big thing that I always see when I run these tests is that my max latency is also higher. So while we saw spikiness in throughput, we also see spikiness in latency. We don't have a really nice latency, predictability or flatline curve like we do when we're running RDMA. So that's really what I want to show you from a demo. So I appreciate you watching my video, and tune in next time for some new updates.